Hello all, welcome to session 92 of Software Testing Made Easy course. In this session, I'm going to explain about equivalence class partitioning, which is one of the black box test design techniques. So let's get started. What exactly is this equivalence class partitioning? In order for you to understand what exactly is this equivalence class partitioning, let me take an example, guys. Let's say there's a text box field which can accept the numbers from 1 to 100. Okay, the users can enter the numbers from 1 to 100 into this particular text box field. Okay, so but if you apply this equivalence class partitioning, what will happen for this kind of text box field which accepts the numbers from 1 to 100? If you are applying the equivalence class partitioning, then what will happen, guys? So as part of equivalence class partitioning, you'll group the inputs, possible inputs, into like this. Okay, what are the possible inputs, guys? 1 to 100. So here you'll say valid inputs. What are the valid inputs, guys? What are the valid inputs? Here in case of valid inputs or anything that are from 1 to 100, any number that is from 1 to 100. So what I will do is I'll pick some random number which is from 1 to 100. Let's say some 75. So 75 will be accepted by this text box field or not? Yes, it's a valid input. One sample I took from this list of valid inputs, that is starting from 1 to 100 of the valid inputs. I took one of the valid input, that is 75. So on the other sides, I'll write something like this: invalid. Okay, invalid input. Here also I'll say invalid inputs. On the left side, what can be the invalid input, guys? So the numbers which are less than 1, right? The numbers which are less than 1 are nothing but the invalid inputs. So it can be 0, it can be -1, -2, whatever it is. I'll pick some random number, -5. So -5 will be accepted by this text box field? No. This text box field is only accepting the numbers from 1 to 100, guys. But if you give -5 here, it will not be accepted. One of the invalid input you are taking here. Similarly, on the other side, if you try to give some number which is greater than 100, okay? If you're trying to give a particular number which is greater than 100, what is the greater than 100, guys? Any number, guys. Let's say if I give 121, it's an invalid input, guys. This particular text box field should not accept the number 121, or it should not accept -5. So how many inputs we got for testing? For testing this particular text box field using this equivalence class partitioning, I got 3 inputs, guys. That is -5, 75, and 121. I'll use these 3 inputs for testing to see whether or check whether this particular text box field is accepting only the valid inputs and not accepting the invalid inputs like -5 and 121. So instead of testing this text box field with infinite possibilities where exhaustive testing is not possible, if I apply this equivalence class partitioning black box test design technique, I can filter out the inputs like this. Using the equivalence class partitioning, I can filter out the inputs like this. That is -5, 75, 125. 3 inputs I got for testing this text box field. Okay. Similarly, I'll give more examples, guys. Okay. I'll take more examples for explaining you the equivalence class partitioning. This is one of the example. So what is the next example then? The next example we have is like, let's say there is a text field which only accepts positive numbers. Okay. Let's say there is a text box field which only accepts positive number. Let's say this is a text box field. Into this particular text box field, you can only enter what type of numbers? Positive number only. So if I have to apply the equivalence class partitioning test design technique here, first of all, valid partition I have to create, right? What is a valid partition? Valid inputs. Valid input. Valid input can be anything, guys. Any positive number is nothing but a valid input. Let's say I'll give 121. 121 in this case is a valid input, right? Because 121 is a positive number and it will be accepted. It is a number and it's a positive number. So it will be accepted by this text box field. What if I try to create a different sets of invalid inputs? Invalid inputs. So what if I give negative number here? Will it be accepted? It's clearly stating that this particular text box field will only accept the positive number. What about invalid inputs? Let's say I'll give -57, which is one of the invalid input. Similarly, other partitions I'll create, okay, for invalid inputs. So this is all based on data type, guys, okay. So if I give negative values, it will not accept. If I give some alphabets, will it accept, guys? No, this particular text box field will only accept the numbers, that two positive numbers. If it is a negative number, also invalid, and if it is a not a number, also invalid. So I'll give my name here, say Arun, okay, as some alphabets, okay, set of alphabets I am trying to input. This particular text box field has to will not accept, should not accept, guys, okay. It should only accept the valid inputs like 121. Any other possibilities are invalid inputs that we can try in this text box field, guys, which only accept positive numbers? Another invalid input we have here is, what if I enter some symbols here? Okay, some symbols. Okay, if I try to enter some symbols like this, will it accept? No, it should only accept positive numbers. This is another test data. Okay, another partition. So equivalence class partitioning. What is the test design technique I am explaining here? Equivalence class partitioning. So as part of this equivalence class partitioning, you are categorizing the test data into multiple partitions. One type of data is valid input, others remaining everything is invalid inputs. Okay, like this we are partitioning. So any other invalid input possible, guys, apart from the symbols, negative numbers, and text? Yes, combination, guys, combination of symbols, negative numbers, and text. Okay, so other invalid input can be, it's a combination of symbols. Okay, it's a combination of symbols, some text, or anything, guys. Okay, anything, it's like this. This can be another invalid input. Like this, at a high level, we have to partition the inputs like this. Okay, to valid inputs and invalid inputs according to the equivalence class partitioning. The short form for this equivalence class partitioning is ECP. We generally call that ECP, equivalence class partitioning. So instead of testing this particular text box field with all infinite possible inputs that may be valid or invalid, exhaustive testing is not possible, right? So we cannot test this particular text box field with all the possible valid and invalid inputs. So instead of that, we'll create this kind of partitioning with this partitions kind of thing with the equivalence class partitioning, where we'll be partitioning a sample data. We'll take only a sample data from a particular partition. So out of all the valid inputs here, you can enter any number, guys, right? 121, not only 121, you can enter any big number also. Only one sample number you will take from valid. From invalid also, you'll take some one sample only. Instead of taking all the negative numbers, you'll only take one sample negative number as part of this partition, like this, guys. So here, how many sets of data you got for testing this particular text box field as part of the equivalence class partitioning? First set of data, second set, third, fourth, five. Total 5 sets of data we got, guys. Okay, we have to test this particular text box field only 5 times instead of infinite times. Fine. So this is what is equivalence class partitioning, guys. Fine. So any other things we have? So apart from this, that other examples, guys. Okay, I'll take another examples how to do the equivalence class partitioning for different type of text box fields which accept different type of data. So the third type is, let's say, guys, let's say there is another example where this particular text box field will only accept mobile number which is of the size 10. Okay, so what is the size of this mobile number? 9912345678, 10 size. This particular text box field will only accept the size 10 number. Okay, so the number should be of size 10, guys. What should we do? How to use the equivalence class partitioning with this kind of text box field which will only accept the number which is of size 10? How to do that? For that, if you apply this equivalence class partitioning, first of all, valid input. What is a valid input? One of the sample input you have to take, this as part of valid input. As part of valid input, you will take a particular number which is of size 10. Okay, you can take any number, guys. 1 2 1 2 1 2 1 2 3 4. So is it of size 10 or not? 1 2 3 4 5 6 7 8 9 10. Okay, any example, valid input which is of size 10 is a valid input. What about invalid input, guys? Invalid input. What is the invalid input in this case? So a number which is of size greater than this 10 size. So invalid input can be like this: 1 2 1 2 1 2 1 2 343434. Is it of a 10 size? No, right? It's not of 10 size, guys. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 size. The size of this number is 14, but this particular text box field will only accept the number which is of size 10. Valid input is size 10, but invalid input is size greater than 10. What about other invalid input? The size less than 10, guys. Okay, let's say I'll give something like 1 2 3. Invalid input or not? Yes, it's an invalid input. If you try to enter this 1 2 3 into this particular text box field, it should not accept, guys. It should not accept, because this particular text box field will only accept the numbers which are of size 10, whose size is 10. Like this is a valid input. These are invalid inputs. So how many times we can perform testing for this particular text box field using this ECP? Three partitions are coming here, guys. One first set of data you'll try to enter into this text box field is 1 to 3, where the text box field will reject this particular value, should reject. Okay, as part of testing, this particular text box field should reject this 1 to 3. If you provide this valid input like this, it should accept, guys. And invalid input like this, which is having the size 10, size 14 digits are there here, right? Then this particular text box field should not accept. So three possible inputs are there, guys, for testing whether this particular text box field is working as expected, where should only accept the digit size as 10. Okay, 10 digits only it should accept. So like this, for that kind of requirement, we have to apply ECP like this. Three partitions are coming in this case. Okay, in this case, we are getting three partitions. Fine. So any other examples? Let's take another example, guys. I can give more examples, guys. Okay. So far, I gave three examples, right? 1 2 3 examples I gave as part of applying the equivalence class partitioning for filtering out the number of inputs from infinite to the possible equivalence partition sets. Now, the fourth example I'll give is, let's say there is some functionality in your application which will only accept, which will only accept credit card payments. Okay, there is a functionality in the application which will only accept this credit card payments. In this kind of cases, guys, if I have to apply the equivalence class partition, how to apply? For that, guys, I'll apply something like this. Valid input or valid details. Valid data is any credit card, guys. Okay, any credit card is a valid. There are different banks, right? HDFC Bank is there. Okay, so different banks are available in the market. So any bank you take, for example, if I take HDFC Bank credit card, only one bank credit card I will take. Instead of taking all the bank's credit cards here, I'll take only one valid input. That is, I'll take HDFC Bank credit card. Okay, this is a valid input. What about invalid inputs? Invalid input. Invalid input in this case is, if I use debit cards, it should not accept. Any other invalid input? Sorry. This is invalid input. Okay, invalid input. One of the example for invalid input is debit card. Debit cards should not be accepted. Only credit cards should be accepted by the application. One valid credit card will take out of all the possible credit cards and we'll put that in the valid input. And invalid input, debit cards. And again, another invalid input, net banking. Customers should not be able to pay using the net banking. Only credit card should be allowed. Any other examples of invalid input, guys? Okay. Any other? It may be like nowadays we got some different mobile app payment gateways, right? Right? Kind of apps like Google Pay or Paytm or something. We'll take one out of them. Like we'll take Paytm. Okay. Paytm or Google Pay or Phone Pay, whatever it is. So that is another invalid input. So like that, guys, you can keep on creating as many number of valid and invalid inputs based on the type of payment it is accepting. Here, type of payment is credit card. So that in order to test whether this particular functionality is working fine, accepting the credit cards or not, I will take one of the sample credit card as part of valid input, that is HDFC Bank credit card. Instead of taking Axis Bank credit card, other bank credit cards, I will take only one. Coming to invalid, I will take, here also I will pick one, guys. Okay, instead of taking all the invalid inputs, here I will take some bank. Let's say Axis Bank debit card I will take. Okay, only one bank. Here also some net banking, let's say, okay, Kotak Mahindra net banking, okay, different banks guys in India they are. Paytm is one of the way you can do the payment, but here it should be treated as Paytm, okay, invalid input. Like that, guys, any type of other payments which are not valid other than credit card. Some example input we have to take like this, fine. And how many inputs how many times we can test this particular payment functionality using these four inputs, 1, 2, 3, 4, and according to the equivalence class partitioning, these four inputs need to be used for testing this credit card payments functionality. Credit card payments functionality should only accept this valid input. All the other cases it should not accept the payments. Okay, if customers are trying to pay using Kotak net banking or Axis Bank debit cards or Paytm, this functionality of the application should not accept. Only this credit card only should be accepted. Okay, this is what, guys, this is what. Fine. So different type of payments and all. So valid, remaining everything is invalid. Okay. So combinations, guys. Sometimes we get some kind of thing where we have to test the combinations. Okay. Most of the cases we'll get the combinations, guys. So let me explain one of the example for combination where we have to use equivalence class partitioning. Let's say there is a text box field which accepts 10 to 20 alphabets. Okay. Alphabet size text. Here into this particular text box field, you can enter some text. If I enter Arun here, guys, what is the size of the Arun? Only 4 alphabets are there. But here, minimum is 10, maximum is 20, guys. But how to apply the equivalence class partitioning here? So there are two ways, guys. First way is like, let's go with the size, guys. Okay. First, let's go with the size. The size of this particular text that you need to enter into this text box field is 10 to 20. 20 to 20 size text should be entered. So for that, if I have to put a valid range, what will be the valid input, guys? Valid input. Valid input for entering the text which is of size 10 to 20 is anything, any size which is from 10 to 20, any random number. Either it can be 10 or 20 or some size of 11, 15 or 14 or whatever it is. Okay, let's say 12 or something will take. If I enter A, B, C, D, E, F, G, H, I, J, how many letters coming? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, KL, 11, 12. Total 12 size. This text is of 12 size. Will it be accepted by this text box field or not? Yes. 10 to 20 alphabet size. Here 12 size is coming. It will be accepted, guys. It's a valid input. What about invalid input? What about invalid input? Coming to the invalid input, guys. Coming to the invalid input. Any size which is greater than 20 is an invalid input. So if I'm giving something like this, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, something. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26 size is coming, right? So this particular text should not be accepted by the text box field because it should accept a maximum of 20. It will be treated as invalid input as part of equivalence class partitioning. Another invalid input where whose size is less than 10, maybe 3, guys, ABC. When you enter ABC text into this text box field, this particular text box field will not accept the ABC because the size of this text that you are entering into the text box field is less than 10. So like this 3 inputs we got, guys. Not only these, guys, here we are clearly saying 10 to 20 alphabets we are saying. Alphabets means they are not numbers, they are not symbols. Okay, so here one more thing, a lot of other invalid inputs are possible, guys. Okay, invalid inputs are possible. What are the other invalid inputs categories, partitions that are possible apart from this less size, greater than size, and possible size? Apart from this two other invalid inputs, there are other invalid inputs possible because here this particular text box field is saying that clearly that it will only accept the alphabets. That means if I try to give some number like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2. Will this be accepted or not? The size is 12 only. You see, the size of this number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 size is there. But here the number should not be accepted. This is an invalid input. Any other invalid inputs? For example, if I give something like this, it's also an invalid input, guys. Size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 size is there. Any size you can give, which is in the range of 10 to 10, 10 to 20, but the data will not be accepted because this is not alphabets, guys. These are symbols. Here only alphabets will be allowed, but here symbols I am providing which will not be accepted. Similarly, other example, other invalid inputs, combinations of this numbers and symbols, guys. Okay, combinations of these numbers and symbols like this. These are symbols. Okay, this will not be accepted because it's neither alphabet, it's neither okay, it's not an alphabet. Rather, it is a combination of symbols and numbers, which will not be accepted by this textbook. So how many possible combinations are coming here? So not only we should check only based on the size of the data that need to be entered, but also the type of the data, guys. Okay. So here, this is all about size of the data. We got 3 inputs, 2 invalid inputs, 1 valid input. Remaining everything is invalid only. Okay. How many invalid inputs came here? 1, 2, 3, 4, 5 invalid and only 1 valid. Fine, guys. Like that. So here range and type. So another example I'll take, okay? I'm just giving more examples because you will get habituated to how to do and all, okay? So text field accepting 10 numerical digits only. There's a text box field which will accept only 10 numerical digits. The size of the number that you can enter here is 10 digit size. Only 10 digit size, guys, okay? Only 10 digit size, not less or more. So what is an example for the 10 digit size? So before I give an example, let's part this into equivalence class. Using equivalence class partitioning, let's do the partitions, guys. Valid input is a number which is of size 10. So if I give 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, valid input or not? It's a valid input, guys. Okay. The size is 10. Invalid input. If I give a number like this, which is of size less than 10, less than 10 size. What is a less than 10 size, guys? 1, 2, 3 is a less than size, right? So this will be accepted by the text box field or not? It is an invalid input, guys. It will not be accepted. Fine. So, and other thing is again invalid input. I'll give a size of a number which is greater than 10 size. Okay, greater than 10 digits. Like if I give something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4. So this is size 14. Okay, size 14, 14 digit size, which will not be accepted by the text this particular text box field. Only 10 digit size, that is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 will be accepted. Apart from this, guys, we can even create more invalid inputs. More invalid inputs. Why? Because they are clearly saying that its digits means numbers. If I give something like this, A, B, C, D, E, F, G, H, I, J. Okay, what is the size? 10 size is there. Size is 10, but the type of the data you are providing here is not number. It is a text, guys, which should not be accepted. Here only number should be accepted. Even though the size of the text is 10, but still the type of the data is not digits. It's like alphabets, so it will not accept. What if I give something like this? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 size is 10, but thing here is these are not numbers, these are symbols which will not be accepted. Other thing may be like combination of alphabets and symbols, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this also is an invalid input. How many invalid inputs we got here in this case? 1, 2, 3, 4, 5. And valid input is only 1. 5 plus 1, total 6 inputs we got, guys, for testing this particular text box field. Here we should also we not only have to test based on the size of the data, but also the type of the data also we have to create the inputs, guys. Okay, invalid inputs need to be created based on the type of the data. This is valid input which has the valid size and valid type of the data, but here this is invalid size of the data, this is invalid size of the data. Here invalid data types. Okay, these are all invalid data types. Here only numbers are allowed, but you are trying to enter text and symbols, etc. Combination of text and symbols. It should not be allowed. So total 6 inputs we got for testing this particular text box field. So hope guys you understood how to use the equivalence class partitioning as part of filtering out the inputs by partitioning the possible inputs, infinite inputs into the only possible inputs, like 6 or 5 or 6, max 10 guys, max 10 inputs you will get any case, fine. Most of the cases you will get max 10 inputs. Here most of our cases we got 6 inputs, right? Some invalid and some valid inputs as part of testing that particular functionality of the application. So hope guys you understood how to apply this equivalence class partitioning black box test design techniques for filtering out the inputs that we can use for performing the testing. So in the next session, guys, I'm going to explain about the next black box test design technique, okay, which is nothing but the boundary value analysis, which is an extension of this equivalence class partitioning. So guys, till then, see you guys. Bye.